Okay, students, we have section 5.4 in WebAssign. This is 5.4 integrals. All right, so these are dealing with the integral of e to the x, which is e to the x. So just like, the derivative of e to the x is e to the x, then the integral of e to the x is also e to the x. But the integral of e to the u is e to the u du, so you have to make sure you have your du and so forth. So we're going to be using substitution, u substitution for a lot of these. All right, so number one is the integral of e to the negative x to the fourth times negative 4x cubed. So normally you're going to let u equal your exponent. If your exponent is a function, well, I should say if your exponent is something other than x. All right, so u is negative x to the fourth. Du is negative 4x cubed dx. So if you notice, that's exactly what we have right here. Okay, so this is really quite easy. It's just the integral of e to the u du, which is e to the u plus c. So substitute the u back in, so e to the negative x to the fourth plus c. And that's your answer. Okay. Number two, e to the square root of 7x over the square root of 7x dx. So it looks like you're going to let u equal the square root of 7x. Let's go ahead and write that as 7x to the 1/2. So our du is 1/2 times 7x to the negative 1/2 times 7 dx. All right, so don't forget how to take derivatives. Just because we're mostly doing integrals, we're also having to do derivatives at the same time. That's why Cal 2 is a lot harder than Cal 1 in most people's opinion. All right, so when you take the derivative here, you've got the power rule and the chain rule. So you brought your 1/2 down, subtracted 1 from the 1/2, and got negative 1/2. Then you're multiplying by the derivative of the inside, which is 7x. So the derivative of 7x is 7. Okay, so let's clean that up a little bit and make it 7 over 2 times the square root of 7x. Okay, so all I did was changed my rational exponent back into a radical, dropped it to the bottom to make it positive. So we have 7 over 2 square root of 7x dx. So as you can see, we have that square root of 7x dx. So I'm going to highlight that. All right, but what we are missing is the 7/2, the 7 over 2. All right, so if I put in a 7 over 2, then to make up for that or compensate for it, I need the reciprocal in the front. So that would be 2 over 7. So this would become 2/7. Write everything now in terms of u and du. So you have e to the u du. So that stays 2/7 e to the u plus c. And we just need to go back and plug in what our u was. So 2/7 e to the square root of 7x. You can go back and rewrite it with a radical. O plus C. We kind of get spoiled with WebAssign putting the plus C for us. I'm sure you don't think that WebAssign spoils you at all, but if you were having to write out your answers on a test instead of them being multiple choice, if you didn't put your plus C, you probably would, I would be nice, I'm sure, and give you partial credit, but some teachers aren't nice. They would count off. Okay. All right, so our next problem, we have the integral of e to the x times times the square root of 5 minus e to the x dx. Okay, so let's let u equal 5 minus e to the x. Du would equal negative e to the x dx. So you can see we have that e to the x and the dx. All we're missing is a negative. So we would need to put a negative in the front. And then we have the square root of u, or u to the 1/2. And you have now your entire du. All right, so use your power rule. So add 1 to the 1/2, which would give us 3/2, divided by 3/2 or multiplied by the reciprocal. So negative 2/3 u to the 3/2 plus c. So negative 2/3 times 5 minus e to the x to the 3/2 plus c. And that'll be your answer. Okay, let's check that. All right, number 4. So we have the integral of 5 minus e to the x all over e to the 7x dx. So anytime, if you have more than one term in the numerator and then you just have a monomial in the denominator, most of the time, I should say, you're going to be dividing, each of your term in the numerator by that denominator. So this would be the integral of 5 over e to the 7x. I'm going to bring that e up to the numerator and make it e to the negative 7x. Minus, and then e to the x over e to the 7x. So think, what do we do with our exponents? We're dividing, so we subtract the exponents. So x minus 7x is negative 6x. So it's minus e to the negative 6x. Okay? All right, so u substitution, our first term would be u equals negative 7x. So du is negative 7 dx. So we need a negative 1/7, and then it just becomes the integral of 5e to the u. We could pull that 5 out to the front as well, either way. All right, our second u substitution, u would equal negative 6x. Du would be negative 6 dx. So this would become, now we have two negatives here. Minus a negative would be a positive. So positive 1/6 e to the u. All right, now remember your u's are two different things here. Okay, so the integral of, and I'm going to put another integral symbol here. I forgot my du on the first term. Here, let me fix this. We'll put my integral after the 1/6. Okay, so pulling that 5 out, we would have negative 5/7 e to the u, and I'm going to put the u back in. The u was negative 7x for that part. And then we have plus 1/6 e to the u, and our other u was negative 6x. You could probably just, do that in your head and not really have to use the u substitution. I mean, this is a pretty simple one. It's just going to be the derivative of that exponent. So I don't think you really need to write out the u substitution per se, but you can if you want. So negative 5/7 e to the negative 7x plus 1/6 e to the negative 6x. All right. Our next problem, we have the integral of e to the negative 8x times the tangent of e to the negative 8x dx. So I'm going to let my u equal negative, or sorry, not negative, e to the negative 8x. Hope y'all can see that. My du would equal e to the negative 8x times the derivative of negative 8x, which is negative 8. So negative 8 e to the negative x dx is our du. All right, so let's look at our problem. So we know this would be the tangent of u right here, and then this e to the negative 8x, and the dx is going to be right here. So we're just missing a negative 8. All right, so if I put a negative 8 in my problem, then I need to put a negative 1/8 out in the front to compensate for that. So negative 1/8 integral of tangent u du. All right, now that's something you can either memorize or you can look it up. The integral of tangent u is the natural log of the absolute value of secant u. So this would be negative 1/8 natural log absolute value secant u. Now that comes from, rewriting tangent as sine over cosine and then using your u equal cosine. So you end up getting like negative natural log of cosine, and then they bring, here I'll write that down up here. So you end up with negative natural log absolute value of cosine x. But what they do is they bring that negative up, that understood negative 1, and make it an exponent. So it's really natural log absolute value of cosine x to the negative 1, which really means the reciprocal of cosine. So that is natural log of absolute value of secant x. Okay, so that's where that comes from. All right, so we needed to put our u back in, which was e to the negative 8x. So negative 1/8 ln absolute value secant of e, let me put a parenthesis here, e to the negative 8x, and let's see, absolute value plus c. Okay, I know it looks a little different in WebAssign. I think the parentheses are going to be in a different place. I do like the fact that you can type in your trig functions and things like ln and pi and without having to go over and hunt them down. All right, so secant of e, it does have a closed parentheses. Well, let's put e to the negative 8x. I think that's correct. All right, let's see if I need a closed parentheses there. So we have an open and a closed right here and here, and then we have the open after the ln and the closed at the end. Okay. Sometimes I just don't trust that I've put it in correctly. Okay. That's interesting. I put it in the wrong box. I wonder if it'll let me cut and paste it. No, it will not. All right, so I need to jot that down real quick because I'm going to have to erase this. So negative 1/8 natural log. Moral of the story, pay attention to which box you're typing your answer in, class. Okay, so let me erase that. Negative 1/8 ln, absolute value, don't forget that, secant of e to the negative 8x, close parentheses. I hate how that absolute value is still grayed out, but I think it's, yeah, it darkened it once I clicked submit. All right, so that was correct. Okay, so the last problem, you need to think about your properties of natural logs and the natural exponential. Remember that they are inverses of each other. So the natural log of e is really 1. All right, so you have to use your property first, though, that the 8x minus 7 being an exponent is going to come down to the front. So 8x minus 7 times the natural log of e. Natural log of e is just 1, so you're really just, forgot my dx, you're really just integrating 8x minus 7. So that's 8x squared over 2 minus 7x plus c. So 4x squared minus 7x plus c. So we gave you a pretty easy one to end this homework. All right, so that's it for this section. I hope you watched, and I hope you continue to watch so you can get your WebAssign all correct and have a good grade for that.